Hello everyone. In today's video we are going to see how to visualize computer CPU processes or processor uses in labVIEW. For that we need .NET block that can be found inside connectivity and then .NET. We are going to use these four nodes: first constructor, then property, then invoke, and lastly close reference. So we are going to use four palettes out of here. So we have pinned it. First constructor node is required. So let us have constructor node. Then here by default I get system 4.0.0. If you don't find it by default, then just go to properties or objects, then system diagnostics, double click here, and then performance counter, this first one. Okay, here there are constructors and we need first constructor. So here we have created one constructor, then we need property node, and this property node should be placed here. Okay, so here we need three properties, and for that we need to define it as, select the class as .NET. First, system diagnostic performance counter. Okay, so now we have properties and we need total three properties. So to change the property, first we need select property and then category name that we are going to name as processor. Then second, select property, counter name, and then third property will be our instance name. Okay, so first property will say that it is a processor. Second, we are going to measure the percentage of processor time, and then instance name shows us the number of processors we are going to use for our work. Right now it's going to read from this block, so we are going to change it all to write. So everything is now going to get input from somewhere. So let us create some constants. So first constant will be processor. Oh. Second is percent processor time, and third is number of CPUs. You can use all the CPUs by writing underscore total. So right now I'm going to give it 1 so that we can visualize the performance of first CPU. So I'm writing 1, and now we need invoke node. Again we'll have to select the method, select the class as .NET, and again system diagnostic performance counter. We got one method, and that method should be changed to next value. Now lastly we need close reference. This will close the reference whenever we stop the program. So let us connect these wires from starting. Okay, let us connect error outputs also. And we need error display also. Create indicator. Sometimes we need to view as an icon or not view as an icon, so that our program will look compact. Okay, now we got next values, and these values are going to show us what is the processor value is right now, or we can use it in a graph also to see historical output. So right now we are going to create an indicator, and this is going to show us the value. Okay, and we need one waveform chart so that we can visualize the historical process data. Again, I need it as non-icon so that my program will look compact. And we need it continuously, so for that we need a while loop. So while loop is here, and we need one while loop close condition, so we'll create a control. Again, you can view as an icon or not. So stop button appeared here. Generally we use a bigger stop button so that if anything goes wrong, it will be handy for us to stop the program. So this is our processor, and this is our processor value. We can visualize the processor value also. So for that we need one indicator that is kind of tank, or let me take it as kind of thermometer. Okay, so this will show us in much better way. So now we have all the program connected. Let us check is there any error or not. So this is showing us processes but very fast, so we are going to stop the program right now, and we are going to provide some delay. This delay is used to run the process or run the while loop with some delay so that we can visualize it. So let us create a constant and let us 1000 millisecond. Let us run the program and see what is happening. So this is our output. The processor is being used 53%, and this much processor use is because of I am running some program here which is a very processor hungry program. So let us use the program to check if I stop the program that is running in background, can we see the processor dip so that we can verify that our program is working properly. So let me stop the program. So now the program has been stopped, and we can see there is a dip in processor uses. Now processor is free from the processor being used from another program. So this is how we can see computer processor output, and we can change the looks and view. So for that we can do what? We can change thermometer like this, and we can elongate it. Now let us run. We can view it much better way. So right now the processor is being used 3%. Let me run the program again and see can we replicate the results. Now we can see that processor is going to go higher as the other program is going to catch up. So other program is going to run, and this is based on deep learning. So whenever the deep learning process or model training process starts, we can see that there is a jump in output processor uses. So it will show like something like this when it is going to start. So let us see what is happening. There are several processes which I have written in this program are going in background. That's why the CPU usage is going high. But whenever the model training starts, this kind of model training starts, it is going to take much more. Look, now our processor is going to have more resources being used. So we can see that the processor usage is now up around 40 to 50%. And this is being replicated here. Okay, so as soon as my process of training or model training started, now we can see there is a jump in processor uses, and we can verify it from here in the chart also. So thank you everyone. This is all we wanted to show you for computer processor recording and visualization. Thank you very much.